Let's go through LeetCode 827, making a large island. For this question, it gives us a grid array, and you can allow to change at most one 0 to 1. We know the 1 is island and 0 is water, and then find the maximal area. For example, this one has 0, 1, 0, 0, 1. For this kind of matrix, if we change, for example, this 0, we make an island like this, the area will be 3. And for last example, 1, 1, 1, 1. It is already every element is 1, so we don't need to make any change. So the area is 4. We have find this kind of grid has data in the length, grid length is similarly equal to 500. And the intuitive way is that we iterate the grid and find if there is a 1, we do the BFS, right? Like there is the classical question to find the area of an island. Use the BFS or DFS to find its area. And for area 0, then do comparison. But if we do this way, we iterate the whole grid. It will be OM carries n square, right? And if we do for each one, we do a DFS or BFS should be n square multiplied by n square, so that will be n4 or n4. So of course this will be out of the time limit. So what we thinking about is that we iterated the grid. If we want to find 1, if we find 1, right? Find 1, we mark this kind of we do DFS or BFS to mark this 1 to be, for example, another number to be 2, and all these islands, if they are connected, then they are marked as 2. And if we find another one, right? We, for example, here we change it to 3, and if we find another one, there is a 4, right? And we use the map to store for each island. For example, the island 2 has the area 4, right? In the area 3, it have area 2, right? So 4, 4, 4, if we have 4, the area will be 3. So we use a map to store island marker integer in its area. Then we do another iteration. If we find a 0, right? Find a 0 here, we try to see on its left whether it's a island. If it is an island, then we add this kind of area to our result on the up and the right and down, right? If this area, we calculate, for example, if we can add this island, and this island. So if that means if we change this 0 to 1, we are add this area and this area and this area. So we can use the map to get the area and add that together, and also add this cell itself. And we iterate the grid for every 0. We try to see whether it is connected on the left up, right, or down if connect to any island, and so that we get if this is 0, we change it to 1, what's the area it make up, and we get a maximum value for that. So let's begin to write code. And in this case, we'll see, because this one we use the map to already use a DFS or BFS to mark this kind of things. We already use the map. So the DFS, it will have O in square time complexity. And also we iterate, after we do the preparations, we iterate the grid again. And it is another O in square. So the total, it is O n square time complexity. And the space complexity, we can create another matrix called marker. And of course, we can also change from this grid to change 1 to 2 or 3, but it change the original input. So if we do change in place, after we finish calculation, what I suggest that for all of the non-zero number, we should revert back to 1, so that it does not change our input. So let's begin to write code. So firstly, let's get int n equals greater than less. We want to do that. We have a marker integer. Firstly, integer map equals a new hash map, and it will store. We are going to change this grid to different island. For example, from the island marker 2 to 2 2. The key will be the marker, for example, 2. The value will be, it's for this island, it's an area. And we are going to iterate the grid. So if grid row equals 1, right? We want to change it to a marker. Let's have the marker here. And yeah, first. Well, we want this DFS to have results. What we are do is that for this DFS we want to change for this kind of island, for example, 1 1 1 1 to our marker to be 2 2 2 2, and also it will return this island's area. So I'm going to have area equals DFS grid row column and marker mark is fine. And we need to map put mark area. So the second one is that we want to write DFS function. The return result will be this kind of area, this island's area, and we are passing grid in the row and the column and the mark. And also, after we calculate, we'll get this grid cell's value to be marked. Let's get A equals 3. Nice. We'll have grid row column equals mark 4. Let's create a direction array. So let's see, initially area should be 1 because for this kind of cell, it is equals to 1, right? Then we do the DFS. So it itself has an area. So for int I equals 0, I is smaller than 4, plus new row, the row of the row I, int new column the column I. So let's say if new row somewhere in 0, or new row greater equals to n, or new column similar to 0, or new column greater equals to n. Or greater new row new column and equal to 1, right? We just continue. Then we need to have area as equal to TFS new 3, new row, new column, mark, return area. Okay, so after this DFS, we do two things. One thing is that we mark each element to some kind of number from 2 to start from 2, right? And every island it has, if they are every cell, if they are island, they will have the same number. So this is the DFS, and also for each island we have a mark, and we have the put that into a map. So after doing this, we are going to have a result. And also we need to iterate into row plus 0, row smaller than n or plus in column equals 0, column smaller than n, column plus. So we need to find a cell. If this is 0, we can flip that to 1, right? So if it's not 0, here we already marked the grid change to different island. So after this DFS, actually, for example, this one originally is 0, 0, 1. After we do this DFS, this become 2, 2, 0, 0, 3. And also we have map 2. The value is 1, 3, value is 1, right? So now we iterate the array. We're trying to find the 0, trying to see whether we can flip it. So so if read row column doesn't equal to 0, just continue. Right? And if it is 0, right? As we already flip it, so we have area start from 1, because for this position we can flip one cell. And we need to use a for int I equals 0, I smaller than 4, I plus int new row equals 0 plus d row I int new column plus column plus d column I. So, so if new row smaller than 0 or new row greater equal to n or new column smaller than 0 new column greater equal to n, we need to continue. And also, for it's for neighbors. For neighbors, we need to area that are equal to map get read new row new comment, right? But here there is some kind of problem. It's for some kind of 0, right? It may on the left and on the up it may belong to the same kind of island. So we cannot just use the add. If they belong to the same island, we already calculate this island area. So we cannot, it will have duplicate adding here. So we are going to use a set. Called set new hash set. Let's have a mark here. Map equal if set contains mk, you also need to continue, right? Otherwise, well, area added is mk and also set add map. So this case we for each cell, if we can flip, if equals 0, right, we have an array here. So that means we find each cell, if we can flip, it has its flipped area will be updated by its neighbors. So we'll have result equals next result in the area. For this kind of scenario, the result, it may, if all of the island, it is, so for example, 1, 1, 1, 1, right? Then we'll see, we cannot find a cell done to equal 0. So the result will, in the after this loop, the result is still 0. But in this case, we should actually return n squared. So we should write return result equals 0 or not, which is 0 to be returned in multiplied by n, otherwise result. From this question, so this will be the brief, the code we write, but there is some small issues that we change the original input of the array. So we should, for our engineering experienced engineer, we should not touch this kind of grid. So we should revert back as a good habit for interval of 0. Not equal to 0. Right now we already marked 2, 3 or those kind of number. Read 0 equals to 1. So this will be our code. 42. Now 42. Area cannot invoke. Mark. Create a new row, new column. New row, new column. Create a new row, new column. So looks like this map. Let's debug this map. Key is 3, 3. Wow, let's see, we already increased the mark, so this is a problem. Actually, it shouldn't. It shouldn't be. Yeah, this is a problem. Actually, we in our DFS we mark as 2, right? So let's take have some other test cases. Have some problem. 0, 0. Because return this one is null. at line 43. Because for this one, we should also have the condition, right? We need to make sure its neighbor is the island. So if mark equals 0, we should continue, right? Yeah. So for this kind of question, the time complexity will be BON squared. And here we are doing in place, right? And of course, if you calculate, this depends on whether you say DFS recursion code have any spaces. If it is, it will be O in square space complexity.